Hello everybody, I am Ricardo Sánchez and I present my final project on fluid transport systems. Cheers to Dr. Osvaldo Vigueras Zúñiga. Let's go. Well, the Venturi effect consists in that a fluid in motion within a closed conduit decreases its pressure when the speed increases when passing through an area of smaller section. A Venturi tube is a device initially designed to measure the velocity of a fluid taking advantage of the Venturi effect. I did knowing the speed before the construction and measuring the pressure difference. The speed is easily found in the measurement section. The classic application of the fluid velocity measurement consists of a tube formed by two conical sections joined by a narrow tube in which the fluid consequently moves at higher speed. The pressure in the Venturi tube can be measured by a vertical U-shaped tube connecting the wide region and the narrow channel. The difference is the higher of the liquid in the U-tube makes it possible to measure the pressure at both points and consequently the speed. Technical description and application. Water will be made to flow with the help of a hose that is connected to one end of the Venturi tube. Likewise, the outlet orifice of the other end of the tube will be obstructed, so that the water level begins to rise until it reaches the maximum height of the siren connected in section 2. Then this obstruction will be removed and the filling time of the two-layer container will be taken. Finally, the process will be repeated 3 more times to obtain an average time and in the same way obtain the flow rate and velocities in section 1 and section 2. Then, using Bernoulli's equation, we will analytically check the experimental results. I am Ricardo Sánchez and this is my project. This is a Venturi tube. Well, water will be made to flow with the help of a hose that connects to one end of the Venturi tube. Likewise, the only orifice of the other end of the tube will be obstruction so that the water level begins to rise until in the reaches connect in section 2. Then the obstruction will be removed and the filling time of the two-layer container will be taken. Finally, the process will be repeated 3 more times to obtain an average time and in the same way obtain the flow rate and the velocities in section 1 and section 2. Then, using Bernoulli's equation, we will analytically check your experimental results. Let's go, everybody.
Ya da igual, si tengo tantas ganas de expresarlo bien, que me hace sentir mariposas como ayer, me hace sentir que tengo 16. Pensaré en algo que no me haga ver patético, mas caigo en cuenta que no puede ser peor. Me apena lo que haces con mi cabeza, que me enrede y que me llevo a otro lado. De solo estamos tú y yo, te juro puede ser mejor, si es que lo sientes bien. Hoy quiero salir a caminar, que tengo sed de ti, de ese dulce amor.
Fabrication. For the manufacture of this instrument, we use two plastic bottles, a 1-inch diameter T-tape PVC accessory, two syringes, hot silicone and cold silicone, one cutter, and one ruler. First, two holes were made in a bottle in the upper part, one the diameter of the syringe and the other the diameter of the hose. The second bottle was made a small hole in the lower part for the outlet of the water. Then I connect a syringe to the upper part of the T, and later the bottles were connected in the transverse part of the T. Finally, everything was sealed with silicone. Conclusion: it can be concluded that the percentage of error of the flow found may be due to the small leaks that the instrument had at the time of assembly. The continuity equation is corroborate signs for the flow to remain the same both at point 1 and at point 2. The velocity in section 2 must increase, and this was verified with the calculations. Likewise, it is observed that the pressure at point 1 is greater than the pressure at point 2.